I want you to think about the data that's on your computer right now. Maybe you have tax info or your family photos, that third grade essay you're so proud of, or maybe even your Doctor Who video collection. Now what if your hard drive crashed and all that data was gone? How upset would you be? If you said more than a little, then I've got good news. You can gain some peace of mind by creating a simple automated backup system using nothing more than a Raspberry Pi and a USB hard drive. It's important to understand what the system is and what the system is not. First of all, this system is simple and totally automated. Once you get it set up, there's no maintenance. You don't have to worry about it. It just runs and backs up your data. Also, you have instant access to your data. There's no decompression or loading external media. You can directly access your data. And finally, the system is configurable. You can save space and time, just like the doctor, by backing up just what you want. You don't have to back up your entire system. You can pick and choose. The system is not a versioning system, so if you mess up something today and then your backup runs, tomorrow your backup is messed up. There's no way to go back to an older version of the file. The system is also not an imaging system. It doesn't take an image of your entire computer so that you can roll back to that image. Still interested? Here's what you need to begin. You'll need a Raspberry Pi and USB hard drive to access the server. You'll need one or more Linux machines and need a backup. For software, you'll need SSH and rsync. SSH gives you remote access to your server, and rsync does the magic of backing up. The nice thing about rsync is it can back up differences. So even though your first backup may take a while, all of your backups after that are incremental and will go very fast. Let's begin by setting up the server. The server in this case is the Raspberry Pi and the USB hard drive. I'm going to connect to my Pi over the network. Then I'm going to plug the USB hard drive into the Pi. If we run dmessage, we can see that the system recognized the drive, in my case, as SDA. So that's what we'll use. I'm using the entire disk, so I'm going to wipe out all the data and create a fresh file system. To do that, I'll first make a partition table. I'm using dev SDA because dmessage told me that's what my drive was. Using a GPT partition table. Making a partition primary for ext4. And I'm using the entire drive. Now let's make the file system. SDA1 is partition 1. Now we'll do a check to make sure that everything is right. And it looks good. So we'll need a place to mount this. I suggest opt backup. So when we go to mount the drive, we need to know which drive to mount at opt backup. The easiest way to get this right all the time is to use the block ID of the drive. So sudo block ID. You can see dev SDA1 here has a UUID of this big long string. So that's what we'll use to make sure that the same drive gets mounted at the same spot on every boot. To do that, we need to edit FS tab in Etsy. So we'll mount using the UUID that we just copied. And that's going to mount at opt backup. It's an ext4 file system. We'll use the file system option of defaults. No A time and no dir A time. We'll use 0 and 2. Let's give that a quick check by saying mount opt backup. Sudo mount opt backup. So it looks like it's mounted. We can also check with mount grip SDA1. We can see that it's mounted on Opta Backup. Let's make sure this survives a reboot. Do a mount, grip, SDA1, and there it is. So that's good. One other change that we want to make sure that we can access it as the Pi user. Right now it's only accessible as root. So we'll just change the ownership, pi.pi. And there we go.